This is part 2 of chapter 8, the atom and the periodic table. So what I want to take a look at now is some information that we can find about the atom. So we talked about previously the different parts, right? So we talked about the protons, the neutrons, the electrons, and their charges when we talked about things like electricity. Now we're going to start talking about how we can put these types of things into an information type chart and what we might be able to use them for. So an atomic number is going to tell us the number of protons in the nucleus of an atom. So sometimes you might see an element written like this. Now remember, an element is one of the materials that's made out of just one atom. So here we've got hydrogen. So we've got the chemical symbol, which is just the shorthand for that element. And the way that this has been written is it's got the atomic number and it's got the mass number written on top of each other. Now we'll see when we look at the periodic table, it's actually sometimes written a little differently. So sometimes you'll see it in this format. Other times you'll see it written in the format you'll see on your periodic table. Generally, what you'll find is that the atomic number is a whole number. In this case, it's showing the mass number as a whole number as well. The mass number is always going to be bigger than the atomic number, and we'll talk about why that is. The atomic number, though, will always tell you the number of protons in the nucleus. And that's just how the elements are arranged, and we'll see how they get laid out on the periodic table here in a little bit. So each element has a unique atomic number because the number of protons give it its properties. So if you add a proton to an atom, you get a new element. If you take away a proton, you get a new element. So if you add a proton onto our element here, helium or hydrogen, you get helium. Because that would be one more proton, and that's going to change that atom. We currently have 118 identified elements that may change in the future. We actually make elements because 90 of those elements are naturally found on the planet, and the rest of those elements are man-made. So any new elements that we discover are going to be man-made elements, and we'll see those on the periodic table. They actually get marked in a special way. In neutral atoms, the atomic number will also tell you the number of electrons. Now we'll see that a lot of atoms aren't going to be neutral, but we assume a neutral atom unless we're told otherwise. And so the atomic number will tell us the number of protons and the number of electrons because they will be equal if the atom is neutral. As you remember, those charges have to balance each other out. Now, as far as atoms go, so the atomic number is always going to stay the same for the atom. So it tells us the number of protons. Again, like I said, if we change the number of protons, it changes the element. But we can have what we call isotopes. And what isotopes are, it's the same number of protons, so it's the same element, but it has different numbers of neutrons. And so we're working on the same element, but basically the mass is changing because we're adding neutrons onto that atom. So up here you can see 3 isotopes of hydrogen. So we've got 1 proton in each of the nuclei on these. In hydrogen 1, which is our normal hydrogen, we've got no neutrons, so it's just 1 proton. In hydrogen 2, we've got 1 neutron and 1 proton, hence the 2. This is called deuterium. And then tritium, for 3, has 1 proton and 2 neutrons. And so hydrogen 3 or tritium is going to be the heaviest out of the hydrogens because of those extra neutrons. All right, so atomic numbers. So let's take a look at what we can know from this? So, how many protons are in carbon? So, where do we find that information? Well, if we turn over to your periodic table, this is why I recommended that you get your periodic table out. We're going to look for a whole number on this periodic table, or the smaller number that's listed with the element. So you're going to look for carbon, for C. Carbon's right here. And so carbon has two numbers here in the box. It has 6 and it has 12.011. So we're looking for the smaller of the two. So the atomic number for carbon is 6. So what I'd like you to do, let's go back over here. Take a look and see if you can find out how many protons are in nickel. And lead. So you may notice carbon's atomic symbol makes sense. Carbon starts with C, same with nickel. Nickel starts with Ni, and then lead, Pb. Thing is that some of the older elements have names based on other properties or older names, and this is plumbum, which is, these used to be used for plumb bobs, basically to be able to tell the center, and so that's why lead is Pb. You'll also notice things like gold and silver have different letters for them as well, and so that's why part of why I give you this periodic table versus some of the others, because it doesn't just have the symbols, but it also has the names of the elements. Some periodic tables don't. Some periodic tables assume that you know what the symbols are for each of the elements. All right, and so I assume you found, I meant to stay over here on the elements table, that you found nickel. Nickel has an atomic number of 28, so 28 protons, and lead is down here. It's one of the bigger elements with an atomic number of 82, so 82 protons. All right, so let's take a look then at how many neutrons there are in uranium-235. So first we need to find uranium on the periodic table. So we're looking for uranium-235. So if you look on your periodic table, you're looking for uranium. Now, a lot of people will try and find uranium up in this section of the periodic table, but don't forget there's another section down here. And this is actually where uranium's at. Uranium's down in the bottom. So you'll see that uranium has an atomic number of 92, which means 92 protons. So the U-235 is telling you the isotope. So whenever you get an element that has the symbol and then a number, that's telling you what isotope it is. So what you're going to do is take that isotope number, the 235, and subtract the atomic number from it, because the atomic number again stands for the protons. When you do that, that will give you the number of neutrons that are left in that isotope. So if you do the math for that, you should get I did that right, 133. So I don't have my calculator. Let me grab my calculator to double check that I did that right. So 235 minus 92, 143. I didn't think that sounded right. So 143 for the neutrons. So let's take a look at, actually, I want to keep that in full screen so we can read it. Switch this one. Let's take a look at another one. So we've got V65. So let's go over and take a look What is V? So take a look, find V on the periodic table. And see, I don't even remember what all of the elements are. There it is, vanadium. I knew it started with a V. So vanadium. So go ahead and find out how many neutrons there are in vanadium. Again, take that isotope number and subtract its atomic number from there. Okay, I believe I have one more. Yep, any more? Nope. Okay, so aluminum 28. So I'm not going to flip back over to the periodic table for this one since you have yours there. So aluminum 28, find that one and determine the number of neutrons. I will make sure that the answers for these are in the PowerPoint. If you can't find them or you don't remember where to look for them, you can always shoot me an email. All right, so atomic mass, we've already sort of looked at this. So the atomic mass is the bigger number here in the box. So atomic number is the smaller one. So in this case for boron 5. And then atomic mass is the bigger number. So 10.811 for boron. So atomic mass is going to tell us the number of protons plus the number of neutrons. So you might be looking at that number and going, well, shouldn't it be a whole number? Shouldn't it be 5 plus, whatever the other number is for the neutrons? Well, so that makes sense, and it should be a whole number. And the atomic mass is going to be expressed in these units, atomic mass units, or little u. This unit is equivalent to 1/12 the mass of a carbon-12 isotope. That's a standard carbon atom, just so that we have a standard. So how do we get this atomic mass? Why are all of the mass numbers percentages? Well, it has to do with the isotopes. Almost every element on the planet has more than one option for their number of neutrons. And so the atomic weight is actually the average of the isotopes based on their mass compared to that carbon-12, so the atomic mass unit, and their relative abundance. So if we take a look down here, they are showing us the calculation. By the way, will not ask you to try and do one of these, just this is here so you can see. So they've got 2 isotopes of nitrogen. These are the only 2 isotopes of nitrogen. So we've got nitrogen 14, because you can see the big one numbers up here for the mass, and nitrogen 15. So those are our 2 isotopes. Nitrogen 14 is the most common. As you can see, over 99% of the nitrogen on the planet, nitrogen 14, and then a very small fraction of it is nitrogen 15. So then what we're going to do is we're going to take their abundance and multiply them by their atomic mass unit. So you can see it's not exactly 14, it's not exactly 15. That's that conversion to the mass unit compared to carbon-12. So you take those 2 calculations, add them together, and that gets us the 14.0067. You can see it's a little higher than what the atomic mass unit is for carbon-14. So this is why you get a lot of these odd numbers on the periodic table that are, 14.006, 16. So and so. So, all right, so that's where we're going to stop for this section. We will pick up talking more about things that you can find on the periodic table and how we can use the periodic table.